Alright, so we're moving on to Chapter 3. These are the video notes for Section 3.1, where we're going to be talking about congruent figures. And some of the concepts in this section are going to be really, really important for uh, the rest of the semester and into second semester as well. So if you have any trouble, make sure you write down your questions and ask me when you have time to work in class, or come see me outside of class. It's much easier to get things figured out at the beginning than wait until after a quiz or a test when you don't do so well, and then try and play catch up. So characteristics of congruent figures, and what we have here are these first two bullet points. These are not formal definitions, so just keep that in mind. It's just some general ideas so you have a visual in your head when we talk about congruent figures. So if two geometric figures are congruent, then one can be placed on top of the other and it would cover it exactly. They would match up exactly. Congruent figures have exactly the same size and the same shape. And we'll be talking a lot about congruent triangles, but that's going to be coming up a little bit later. And then dealing specifically with congruent figures, those parts that match up, so the same size and shape, when we cover them exactly, the parts that match up, the parts that lie on top of one another, those would be called corresponding parts. Okay, the parts that would match up if the figures were placed on top of each other. These can be points, they can be angles, they can be segments. When we talk about naming the angles and the segments, it's the order that we name them is going to be important, and I'll be calling that corresponding order. That's going to be important. So you must be able to identify corresponding parts to be successful in this chapter. I think it's important. Okay? Alright. So let's take a look at a basic example, just practicing naming corresponding parts. So we're given that these two figures are congruent. So we've talked about segments being congruent. We've talked about angles being congruent. Now we're talking in this particular example about quadrilaterals being congruent. So the order that these are named, A, B, C, D, is congruent to quadrilateral F, R, Z, T. The order that these are in is important. So that means if I were to place these figures on top of each other, A would match up with F, B would match up with R, C would match up with Z, and D would match up with T. Those are the pieces, or the points in this case, that correspond. So when we're talking about the corresponding segments, we can use this congruency statement to help us name our segments and our angles when necessary in a corresponding order. So the segments that correspond, it would be segment AB would correspond to segment FR, and since the figures are congruent, these are going to be congruent. And we'll talk about that in a minute. So these are the corresponding, one pair of corresponding segments. Notice how I named A first from the first quadrilateral. Here's A first. I would name F first as well. So then if we look, so that's AB. Now this segment at the top, I'm going to actually name that CB. So if I name that segment CB, how do you think I would have to name that corresponding segment over here? So feel free to try and fill that in. Since I started with C on the figure on the left, I'm going to want to start with Z on the figure on the right and call that segment ZR. Now, most of the time it's not going to really matter the way that you name these, but when we start trying to prove triangles congruent and other figures congruent, it's going to be important for us to name them in a corresponding order. So then we've got segment CD, and again we can either see how they match up in the congruency segments. Here CD, third and fourth letters, so they have to correspond to ZT, third and fourth letters in the other quadrilateral, So, but we could see that in the picture as well. And then the last pair of corresponding segments, if you haven't written those yet, would be AD congruent to FT. Okay, so the order that we write our letters now is going to be important. Again, if you have a question about that, make sure you write it down and ask me in class. Now the angles, it's going to be the same way. Since A is first, it's going to correspond to F, so I could write angle A is congruent to angle F. Okay, if I wanted to use 3 letters, I could. In this case, there's no confusion if I just use one, but for example, angle A I could call angle BAD, and that would be congruent to, since I went B top, A underneath it, D to the right, I'm going to do the same thing over here and call that angle RFT. Alright, angle, let's get my angle symbol in there, angle RFT. Okay, in this case we only need to use one letter, so for the remainder of them I'm just going to use one letter, but keep in mind the corresponding order of the letters naming angles is going to be important as well. So then we've got angle B is congruent to angle R. That's another pair of corresponding angles for these two congruent quadrilaterals. Angle C is congruent to angle Z. And the last one would be angle D congruent to angle T. So moving on to definition, which we kind of alluded to in this example. If triangles are congruent, so now we're specifically talking about triangles. If triangles are congruent, then all pairs of corresponding parts are congruent. That means that all the pairs of matching parts, so since they're triangles, triangles have three sides and they have 3 angles. So that would mean that the 3 matching pairs of sides would be congruent, and the 3 matching pairs of angles would also be congruent. If the triangles are congruent, then the corresponding parts are congruent. Alright, and since this is a definition, we'll have a converse. You want to add these to your theorem sheet. If all pairs of corresponding parts of 2 triangles are congruent, then the triangles are congruent. So if we think ahead here, and we're trying to figure out how to get triangles congruent, this definition would seem to tell us that we need to get all pairs of corresponding parts of 2 triangles congruent. Then we would know that the triangles were congruent. Okay, so that would be 3 pair of sides and 3 pair of angles. That would be 6 pair of parts. So fortunately that won't be the case, but we'll see that once we start proving triangles congruent. But based solely on the converse of the definition, we would need 6 parts. We'll talk more about that soon. Alright, so another example, looking at triangles, we want to name all pairs of congruent corresponding parts if triangle KER is congruent to triangle KNR. So let's start with the segments. I've got KE congruent to KN. So you notice they have this side in the middle in common. And then I've got ER is congruent to NR. So since they're triangles, they have 3 pair of sides, so we should have 3 pair of corresponding segments. You notice that they meet in the middle at KR, so KR is actually part of the top triangle and a part of the bottom triangle. So the way we write this, which may seem a little silly at first, but you'll get the hang of it, is segment KR on the top triangle is congruent to segment KR on the bottom triangle. So before we go ahead and do the angles, you could see this is called the reflexive property. So we have a segment congruent to itself. The reflexive property, it's a postulate. It's something we assume to be true. If a geometric figure is a segment, then it is congruent to itself. Or if a geometric figure is an angle, then it is congruent to itself. So keep in mind that we're going to have another exception to our if-then rule in proofs. In proofs, write reflexive property. Okay, if you want to write out the if-then statement, make sure that you write out the correct one for segments or for angles, but really all you need to write is reflexive property. Alright, so let's go ahead and let's name our angles. I've got angle E on the top is congruent to angle N on the bottom. And then I've got this angle over here and this angle over there, so that's angle EKR is congruent to angle NKR. And then I've got these angles over here. Angle ERK is congruent to angle NRK. Alright, so a lot of important things going on in here. Notice how I named these in corresponding orders. We've also got a reflexive property over here. That's new for us. Another thing that we're going to talk about in this section, which I'm just going to briefly mention in the video here, are transformations. So a translation is a shift or a slide. So if I have a segment over here and I just slide it to a different spot, okay, that's a translation. A reflection is a mirror image. So if I have, let's say I have half of a graph here and I reflect it over the y-axis, okay, I'm reflecting it, or I could have a rotation. Basically, we're just spinning something around a point. The point could be on the figure, it could be off the figure, and again, we'll talk more about these. So moving on to the example, we want to justify each conclusion based on all this information that we have. So I know that M and N are midpoints, so I know that these two segments are congruent here, and since DC is congruent to AB, and I know that M and N are midpoints, then these have to be halves. So actually all four of these segments are congruent. I've got angle 1 congruent to angle 4, and angle 2 congruent to angle 3. Alright, so why don't you go ahead and see if you can come up with a conclusion for each of these. Go ahead and pause the video, and then when you restart it, we'll have the answers there, and then you can check. And again, if you have questions about why any of the reasons are what they are, make sure you ask me. Okay, so here are the answers to A, B, C, and D. If congruent angles are added to congruent angles, then the sums are congruent. Part B, if segments are congruent, then their like divisions are congruent. Part C is the reflexive property, and if you notice up here it says BD congruent to DB, so see if you can figure out why those are switched around like that. And then the last one, if segments are congruent to the same segment, then they are congruent. That's one of our forms of transitive property. So go ahead and check yours, see how many you got right. If you have questions about those, make sure you ask me in class, and we'll see you next time.